See what we're looking at here. So if sine y equals cosine x, which of the following statements is true? So the idea is that if sine y equals cosine x, and this is one of those co-function things, it means that y is equal to 90 minus x, or x is equal to 90 minus 1. It doesn't matter because they're the other angles in the triangle. Okay. So but it is not the case that that they equal each other. It just means that it's like if y is 40, then x is 50, or if y is 82, x is 8. They just have to, sorry, 50. They have to add up to 90 each time. Is that clear
Yeah.
or not? I mean, that's the whole, like, well, one angle is 90 and the other two angles have to add up to 90. Is that so? I think what could be confusing here is because they're in different triangles. You got y in one triangle and x in the other. Well, what it really means is that y is really z and x is really w. And I know it's a weird mapping, but that's what it is.
Because I always thought that would be y to x, and you're flipping it and be y to x, so then it'd be ABC to FED, but I guess it'd be W to X, but it's kind of like rotating it.
Kind of. It's more like this: w plus y equals 90 and x plus z equals 90. And then you have to use either y equals 90 minus x, or you use x equals 90 minus y to establish the relationship.
Uh, all right. So yeah, I think that makes sense. I would be W to X.
Sure.
So make it the next question.
All right, Liz, we're trying to find a rectangular canvas where our project is height must measure 18 inches and form a 48-degree angle with the diagonal at the top of the canvas. What is the length of the diagonal of the canvas? Okay, so like what's not clear to me. Okay, so we know that the height is 18 and there's a diagonal here. What I can't tell, and I'm gonna read it one more time, the angle with the diagonal at the top of the canvas. So I think that this one is 48 degrees, the way I'm reading it. Do you have your previous drawing to know if this is what you came up with?
I think that's what I did as well.
Okay, so that by alternate interior angles, this is also 48 degrees. So then the sine of 48, what are we trying to find? Oh, find the length of the diagonal. Yeah, sine of 48 degrees equals 18 over the diagonal. So D is equal to 18 over sine 48.
Got it.
So here's the problem. Well, I got exactly what you got, which means that it probably is not. It's probably 52. Huh. So this does not work. This gives you the 24. So this can't be right. So let's do it differently. And I don't know how you would know. I mean, it's based on, so let's say that's 48 degrees. You can say the cosine of 48 equals 18 over D. So D equals 18 over cosine 48. And go ahead and calculate. I'll be right back with you.
Mm, so that's how they got the 27. Yeah,
Did that turn out to be 27?
yeah, it turned to be 26.9. Like, so you round it to the nearest inch would be 27. Yeah, that
Okay,
makes
good.
sense. No. But then just one.
Boy, here's a biggie. All right, rectangle ABCD has vertices. They're giving you the vertices there. Okay, and they're just labeling the points. Which statements could help prove that diagonals have the same midpoint? Okay, so the midpoint means it's in the middle. It's obvious, right? You would want to find the, actually, you'd want to find the midpoint to do this. I mean, it seems like such an obvious thing. So this is distance formula. This is distance formula. This is slope. And this is midpoint formula. So therefore it must be D. And it is that simple. It is that like,
Okay, there's a bit. Yeah, that makes sense.
so we got a new question here. All right, so I feel like we've done this one a bunch. Did we just not do this right the last time?
I believe
Like we
we
got to
did.
find the distance from A to B, B to C, D to C, and A to D. So from A to B, it's a triangle 4 and 1. So it's the square root of 4 squared plus 1 squared, which is the square root of 17. From B to C is a 2 to 2. 2 squared plus 2 squared, so it's the square root of 8. B to C, you're going 2 and then 7. So it's the square root of 2 squared plus 7 squared, which is the square root of 53. And then A to D, same thing here. We're gonna drop down 6. Looks like 6 drop down, right? 4. 6 squared plus 4 squared, square root of 52. So you wanna just put these all in your calculator together. Just don't even round, just put them all in your calculator. I mean, you shouldn't be that far off. Like it should be like 21.389 or 21.421. But go ahead and calculate this on the right here and see what you come up with.
We got 21.44727. So
I bet,
basically,
yeah.
yeah,
So,
then
right. So I don't know what happened. I mean, maybe I gave you the wrong numbers at some point. Maybe, who knows, right? So I don't know, but
I mean,
make sure.
yeah.
Right. All right, the quadrilateral KLMN is a rectangle and has an area of 20 units. Give two of the vertices. Determine the coordinates of point J. Okay. So the thing here is the area is that's how important it is. So the area of the rectangle is 20. What is the base? What is the base area? I'm sorry, base length here,
5 units.
5. So the height must be what to get to 20?
The height has to be 4.
Yeah. So you have to go up 4 from that point.
So that would give you, I think it's 5,0. That would give you 4, 0,4. So,
Well, that's over here at L. I mean, that's true, but you want to
oh
go from
yeah,
N because we're trying to find point K.
so it'd be 5,4,
Yes.
the 5 units. Got it. Um, alright. So I have more of a question for this one. You see this what I mean, but wouldn't you equal the 3x and the x plus 20 to 180 and then
Let me get it up here before I make any comments.
there's the
Diagram below, measure of angle A is 3x, measure of angle B is x plus 20. It was the value of x. So here's the thing is AB is congruent to AC. AB is congruent to AC. So what that means is that it's an isosceles triangle, which means that the base angles are also congruent, which means that this is also x plus 20 over here.
so would it just equal all 3 of them to 180 and then solve for
Yes,
x?
yes, exactly. So go ahead and work that out, please.
I got x equals 28.
X equals what? 28?
Mhm.
Okay, seems reasonable to me. Are these like new style of questions or like, are they from a test review or what's going on here? Because they're not the
Um,
usual, with the, like these with the radio buttons.
oh, these are just from like a separate, these are kind of like worksheets I looked up separately for review because
Okay,
I feel like they're reviewing for the final. So a lot of them are like, the term of the type of problem are like the ones from the. I think this one might be the one to go around, put it in the chat. Okay, the next.
So this is, I mean, just, again, like, just be careful because this is out of scope for your class. But, I mean, we can certainly do it. I'm just letting you, like, you haven't done anything like this, at least as far as when we've been working together. Um, so centroid. The centroid, it connects the vertex, each vertex to the midpoint of each of the other ones. So you've got to find the midpoint of BA, AC, and BC. So I guess I'll have you start with that. Go ahead and find those three midpoints for me, please.
I got 5,6 for BA, the midpoint of BA.
Okay, keep going, keep doing the rest.
And the got 9,6 for AC, and then for BC.
That
To
9,6.
was
Okay.
it's I got 7,3 for the midpoint of BC.
Okay, so 5, 6. There actually use a different color here. Red, get that one. So the idea is that you connect the vertex to the opposite one. And because I'm doing it by hand, it's not as good as, but right there is the centroid, that big fat dot.
Uh, mm,
So I think that, I mean, that does it, sort of a 7,5 is what it looks like.
this is one of them they wanted to go over. This is from the from our set of questions. This is from the volume portion. So
Okay.
let me put it in the chat.
Alright. Okay, yeah, so there's two ways to do this problem. The first is to literally just recalculate the volume. So you actually don't care about the original. The original isn't important, but so the dimension of the globe reduced by half. So what that means is that the new diameter is 8 inches, but you actually don't care about the diameter. You care about the radius. You care about the radius being 4 inches. Okay, so you have a globe or a sphere. Radius is equal to 4. Volume of the sphere is 4/3 pi r cubed. So they want you to use 3.14 and 4 cubed like that. So go ahead and calculate that. I'll be right back with you.
Yeah, now I got 267.9.
All right, so did you get this 267.9?
Yeah, yeah,
Okay. So who knows what happens? Maybe you use the 8 as the radius, I don't know. Doesn't really
yeah, I
matter.
think that's what I might have done, like using the original as the. So, a little bit. So here's the next one, kind of the same test. This was,
As part of a new advertising campaign, a beverage company wants to create dimensions of cans by multiple 1.1. Okay. Cans are currently 12 centimeters tall, 3 centimeters in diameter. Okay. How much more? Okay, so I see. So I believe what happened is that we calculated the new volume. We didn't calculate the difference, but let's run through it. So the current volume is this. And so the new volume is we need to take 12 and multiply by 1.12 and 6 and multiply by 1.12. So could you do that for me, please?
well, the 12 times 1.12 is 13.44,
Okay,
and 6 times the 6 times 1.12 is 6.72.
good. Okay. So the thing is though, is that the second one's the diameter. And we don't really want that. We want the radius. You're gonna have to cut that in half. So divide that number in 2 and let me know what you come up with.
That's 3.36.
3.36. Okay. So that's the radius. That's the height. So the volume is pi r squared times h. And they're saying again to use 3.14 for pi, 3.36 for r, and right, it's 13.44. So go ahead and
So
calculate this
that's,
volume.
yeah, that's gonna be 476 point
Right. So this is where
four
and this is
39.
where I'm very negligent because I'm not reading the questions as carefully as I should be. When it says how much more, what that means is
So that means that like you have to subtract
hit
the
subtract. You have to subtract out the old one, and that will give you
339
the 137.12.
to 9. Whoops, 9. That would give you 137.319, which I guess you rounded to the nearest hundred, giving you the.
Well, close, if you're gonna go into engineering or anything like that, it's close enough. Like you don't need to, it's good enough. If it's within the right spectrum, you just go with it.
uh, Yes. Look it up. This one's in a different model part of it. It's in the chat.
So look here. Find the Y values such that DI and EI form a three. So that was one of the things I was messing over with. It's a 3/5 rate, 3/5 ratio. So you need to, let's say this, you need to get the coordinates of D. D is -3, 2, and E is 5, 5. Okay. So what is the distance? What is the Y value difference here? How much is that?
3
That
units.
going? 3 units. So you need to take 3/5 of 3 units and then add that to the initial Y value. That should give you what you're looking for.
Yeah, I got 3.8. So
Fantastic. So that's, so the issue was that I was using a traditional ratio, which is not what they were meant, because I'm not, I didn't, it doesn't matter, but that's,
no wait, but so let's see, so it's the Y value, but I still got 3.8, 3.8. Technically, it's 3.8.
oh, you're right.
I'm
Well,
not sure how they got 3.125.
let me look here. Maybe I missed something. -3, 2, 5, 5. Okay, difference is 3. So we know it's got to be up a little bit. 9/5 is 1.8 plus that. Ah, so if we go maybe we were using the wrong numbers. Maybe we need to be using the X numbers. So that would be 3/5 of 8. That would be 8 there. But that will still not quite. See, that's where I thought this was. So this, if it is 3/8, 3/8 of 3/8 of 3 would give you the right answer. And so how did I get, you take the first number 3 over 3 plus 5 to get 3/8. So that should work. You follow that or not?
Yeah, but a little bit. Then you do 3.8. So 3. Yeah, then I get 3.125. Yeah, that makes sense. Yeah, so you can see the right way to do it. here. Okay. All right, I think that's gonna be it for us today, actually.
That's all you want to do for now?
Yeah, I think that's getting over everything that
Okay,
we kind of got wrong and kind of need to.
all right. Well, we got another lesson scheduled for 4, so come ready with questions and I will see you then.
All right, fine.
Thank you so much. Bye.